you remember before we have the xy and then xy prime, we have this kind of transformation. We simply extend it into 3 dimensions, okay? And then here we use the symbols L1, L12, L13. This one representing is this one. If we are given the old, this is the old corner system XYZ, and if we rotate into the 3-dimensional, for example, say this is the x prime, okay, and here the x, y, z, x prime, y prime, z prime, they represent is the unit vectors in that direction. Okay, so in this way, you can see compared to our directional cosine, if you replace the n by this x prime, basically the L1, 1, 2, 1, 3 representing is the directional cosine of that vectors into the old one, right? So this is alpha, beta, gamma, and that is here. And you simply repeat this process to another y prime, z prime axis. Okay, and then we'll look at the example here. So let me make a better drawing. So in terms of my original notations, and so let me draw the x1 cube. So this is the x1, x2 plane. So if we rotate by any angle theta, so the new polar system will become like this. Let me call this x1 prime, x2 prime, and x3 prime, right? And now, for example, say in my exercise, I designate this is our n. So basically here we can do this one. We can write it up this corner system here. x1 prime, this is the angle theta. x1 prime, this has the coordinates. x1 prime has a coordinate in terms of the old corner system, that is cosine theta, sine theta, 0, in Z. So that is, I think that's your question here. And let me continue. For x2 prime, we have a coordinate. If you look at this one, let me project in x2 prime. I don't know how to do that one. So this is theta.
Because x2 would be the tangent, right?
Yeah.
Oh, that's
So,
terrible.
so this amount is.
Wouldn't x2 be the?
No, because it's rotated theta from x2 axis.
No, I'm saying wouldn't x2, like the original x2, wouldn't that be the wouldn't that be the hypotenuse?
No.
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 Okay, so basically here, let me put into 2D.
Yeah.
So this is x1, x2, and we rotate.
Oh, wait,
into
never
each
mind.
one here. x1 prime, x2 prime. Okay? So in this way, the x2 prime has the coordinates. This one is cosine theta. This one, the magnitude is sine theta, but in the opposite x1. So this is minus sine theta, cosine theta, 0. For the first one, that one is the same as x3, so that is 1, 0, 0. Okay. So that means here, for example, if we put our probe n in x1 prime, then the first row will be our n. If we place our n vector to this direction, then we pick up the second row as our n.
So
Yes.
Quick question, are you always gonna give us something where it's rotated about a certain axis, or are you gonna actually give us like a point in space
Yes.
where, like,
Yeah.
therefore we don't just
If
use
it's-
theta, we have to use like alpha, gamma, and beta?
Yeah, I think for bigger exercise, I will try to give you this information.
Okay.
Okay, give this one, because here we are not in astrodynamics, otherwise I will give you is this one. For this one, I will try to give you this matrix information. Okay, or I will designate what is the contents of the M to you. Yes,
What would you do if you rotated about two different axes at the same
Yes.
time?
Well, you would
And
do one and then one,
then-
you would do one and then the other, right?
yes,
So
so,
you do one transformation at a time and just sum the components?
I don't know whether you have learned in your dynamics, fundamental dynamics, about the, Euler angle. How to pronounce Euler angle or Euler angle? Euler's angle. For rotation of the corner systems, respect to the axis, we can do this sequential. We can decompose into sequence,
Okay.
and then in every single sequence we about one axis, and then go to the next one, then we about another axis.
So you do the transformation and find the reactions in one axis
Yes.
and then sum,
Yes.
do superposition
Yeah.
for each transformation?
Yes, and then that one, the result will be the compositions of will be the multiplication of the matrix. And that one is we say very clear in, if you like, Sarah may have the notes, or otherwise I can provide you the notes. Okay, but here we don't talk about those kind of things. Okay, so today we finished the Cauchy formula, and then probably Monday I will, based upon this figure, and then we talk about the principal stresses in 3D. And the principle, I will talk about the principle, but the calculation should be very easy. But you have to use MATLAB, okay? And that is the one. But in terms of the homework and testing, I think to this step is the farthest point I want to go, and no more further. Actually, for those kind of contents, beyond this point will be more going to the advanced mechanical theory.
I remember that.
Okay, so I will try to give you certain results, but on the testing, I won't go that way. Okay.